Hi dear students, today we are going to discuss something very important and very interesting. That is, what is logarithm and what are its properties. We'll be proving all the properties of log. And you know what are the properties of log? First property is log of m into n is always equal to log of m plus log of n. And the second property is log of m divided by n is equal to log of m minus log of n. And third property is log of m power n is always equal to n log of m. And fourth and last but not the least property, that is log of n to the base n is always equal to 1. This is going to be a very important and very interesting lecture for all of you. Stay with us and let's start the video. Okay, first of all we'll be proving the first property of log, that is log of m into n is always equal to log of m plus log of n. Before proving this property, you must be aware about the fact that we can write a number into two forms. First is exponential form and another is the logarithmic form. If we have a raised power x is equal to y, that means this is the exponential form of a number. It can be converted into logarithmic form, or we can convert it into logarithmic form. How? We write log of y to the base a is always equal to x. And this is called the logarithmic form and this is the exponential form. I have already discussed about all these things in my previous lecture. You can go and watch that very lecture. I have given the link of that very video in description box. You can just go and watch that video as well. So let's prove this property, log of m into n is equal to log of m plus log of n. And one more fact you need to take into consideration is the base for all the properties is same. The base which you take on the left hand side must be same as the base you take on the right hand side. So let's take the base a. Let's write put log of m to the base a. Here the base, let's take base a and a. Log of m to the base a is equal to x and log of n to the base a is equal to y. Okay, as you know, we need to find out the m and n, product of m and n. Let's convert this log form and this log form into exponential form. How we can convert it into exponential form? I write a raised power x is equal to m and here a raised power y is equal to n. This is how we can convert the logarithmic form into exponential form. As you know, we need here m into n. So we multiply equation first and equation second. Let's name this equation first and this one as second. If we multiply, let's multiply equation first and equation second. What we get? We get a raised power x into a raised power y is equal to m into n. As you know, we need m into n. So I can write m into n on the left hand side. I can write m into n is equal to a raised power x plus y, because bases are same, powers can be added. Okay, is it clear? Okay, if there is any confusion, you can just rewind the video, watch it again, and I'm damn sure you'll be able to understand each and every step regarding this property. Okay, so this is m into n, product of m into n. Let's convert it again into logarithmic form. Here base is a, power is x plus y. I can write log of m into n to the base a is equal to x plus y. Okay, do you know what x is equal to? X is equal to log of m power n. So we'll be replacing x by log of m to the base a. So I write log of m into n to the base a is equal to, instead of x I will write log of m to the base a plus, instead of y I'll be writing log of n to the base a. This is log of n to the base a. This is how we can prove the first property of logarithm, that is log of m into n is equal to log of m plus log of n. I hope you understood each and every step regarding this property. Now on the second stage we'll be solving the second property of log, that is log of m by n is equal to log of m minus log of n. As in the previous example, I substituted log of m and log of n as x and y. As I just said that the base on both the sides must be same. So let's put log of m to the base a is equal to x and log of n to the base a is equal to y. Okay, is it clear? Okay, now I'll be converting these logarithmic forms into exponential form. Here base is a, I will write a raised to power x is equal to m and a raised to power y is equal to n. Let's name these equations first and second. Okay, as you know, we need m divided by n. In the previous example, in the previous property, we multiplied the two equations. In this example, we'll be dividing first by second or second by first. Okay, let's because why we divide in this example, because I need m divided by n. So divide first by second, I mean equation first by equation second. This is a raised to power x divided by a raised to power y is equal to m divided by n. Okay, is it clear? Okay, now I will write on the left m divided by n is equal to a raised to power x into a raised to power minus y. One more step, I write m divided by n is equal to a raised to power x minus y. Same property, bases are same, powers are added, and in case of division, bases are same, powers are subtracted. Now let's move ahead. Apply log on both sides, or you can say just convert this exponential form into logarithmic form. Here base is a, I can write log of m divided by n to the base a is equal to x minus y. As you know, x is equal to log of m to the base n. I'll be replacing x by log of m to the base n to the base a. This is log of m divided by n to the base a is equal to, instead of x, I will write this one, log of m to the base a. This is log of m to the base a, and I'll be replacing y by this one, log of n to the base a. Log of n to the base a. And this is how we can prove the property number second. I'm damn sure you're able to understand each and every step regarding the properties and the proofs of all these properties. If there is any confusion, you can just rewind the video and watch it again, and I'm damn sure you'll be able to understand each and everything. Now let's move to the property third. This is not property 1, this is property third, and property third is log of m power n is equal to n log of m, and of course to the base a and to the base a. So let's start with the same procedure. We'll be substituting log of m to the base a is equal to x. We don't have log of n this time, so we'll be just substituting log of m to the base a is equal to x. If I convert this log form into exponential form, I can write a raised to power x is equal to m. Okay, as you know, I need m power n, so I'll be raising power on both sides of this equation. Let's name this equation by 1. And as you know, I need m power n. Here I need m power n, so I'll be raising power n on both sides. So I'll be writing a raised to power x whole raised to power n is equal to m power n. Okay, let's simplify this. This is x and this is n here. Okay, I can write a raised to power nx is equal to m power n. Okay, if I convert this form into logarithmic form with base a, this is a raised to power, or you can simply say log of m power n, which is on the right hand side, to the base a is equal to nx. Okay, is it clear? I just converted the exponential form into logarithmic form. And let's move ahead. This is log of m power n to the base a is always equal to n. And here instead of x, I'll be replacing x by log of m to the base a. So instead of x, I will write log of m to the base a. And this is log of m power n to the base a is equal to n log of m to the base a. And I hope you understood this property as well. Now finally we are going to solve the fourth and last but not the least property of logarithm, and that is log of n to the base n is always equal to 1. Let's start by the exponential forms of different bases. We have a raised power 1 is equal to a, 2 raised power 1 is equal to 2, 3 raised power 1 is equal to 3, 10 raised power 1 is equal to 10. If I try to convert all these exponential forms into logarithmic form, what will happen? I'll be able to get log of a to the base a is equal to 1, and here log of 2 to the base 2 is equal to 1. In this exponential form, I'll be writing log of 3 to the base 3 is 1, and finally log of 10 to the base 10 is equal to 1. These are the different cases of log with the same base, log of a particular number with the same base, and you can generalize the fact that log of n to the base n is always equal to 1, and I can prove it by converting exponential form of a number into logarithmic form. How? You just wait. We know that for any natural number n, n raised power 1 is always equal to n. So if I try to convert this exponential form into logarithmic form, here base is n, power is 1, and it is equal to n. So I can write it as log of n to the base n is equal to 1. This is how we can prove this fourth and last property of logarithm, and I hope you understood each and every property of log. And if there is any confusion, you can just rewind the video, watch it again, and you'll be able to understand each and everything regarding the basic definition of log, regarding the exponential form, and regarding the logarithmic form. This is all for today. We'll be meeting in the next lecture. Till then, goodbye.